Hello, good morning, welcome. We're going to have a very quick lesson today reviewing a horizontal reflection and a vertical reflection. So before I show some examples, some quick reminders. If you have a negative before a function or in front of the function, you can think of it as like the coefficient to whatever function you have. In your graph, that's going to reflect your graph over the x-axis. So you can think of it like a horizontal shift, a horizontal reflection reflecting over the x-axis. So we'll see some examples of this in a second, but just keep in mind when the negative is outside of the function, or the negative's in front of the function, it's going to reflect over the x-axis. When we have a negative inside of the function, it's going to cause a reflection over the y-axis. So it's going to cause a vertical reflection. Okay, these are just words, so let's see what this actually looks like. So I have my parent function of y equals x cubed. This parent function looks like this. And what I'm going to try to do is apply the transformation. So the change that's happening in this function is this negative. And what I want to ask myself is the negative inside of the function, or is the negative in front of or outside of the function? So going back here, I want to again ask myself, is the negative outside or inside? And hopefully it makes sense when I tell you that this is inside of the function. It's inside of the parentheses. It's inside of the operation of being cubed. So this is going to result, let me double check. If it's inside, that's going to reflect over the y-axis. It's going to be a vertical reflection. So reflecting over the y-axis essentially means that the y-axis is my line of reflection. So let's use this point up here. If this point it is originally 2 units right of 8, when I flip it, it has to be 2 units left of 8. So explaining it with words might actually make it harder because it's a pretty visual idea, but let me just show you that one more time. If this is the original function, just chilling right here, then when I reflect over the y-axis, I want to make sure it's the same distance from the y-axis that it was before. So I'm reflecting over the y-axis like a mirror reflecting the image. Kind of like when you take a selfie on your phone, it's the reflected image of your face. Fun fact. It's not your real face that you see when you take a selfie. Okay, let's try another one. So an inside change results in a vertical reflection over the y-axis. An outside change results in a horizontal reflection over the x-axis. Okay. Let's not do this one yet. I'm going to do another example first. Okay. So this inside or outside of the function? The original function, the parent function, would be a quadratic, x squared. And I want to think, is this negative inside or outside the quadratic? This, even though it's like next to the x, it's still considered outside because there's no parentheses. So if there's no parentheses around here, then we're assuming that the negative is the coefficient. It's actually outside of the function. So looking back, when it's outside of the function, that's going to be a horizontal reflection over the x-axis. So what does it look like to reflect something over the x-axis? Again, there are no parentheses. The negative is considered outside. So reflecting over the x-axis, I can use any of these blue points, and I want to make sure when I flip it, it's going to be flipped to the same point but below the x-axis. So this time, instead of flipping side to side horizontally, side to side vertically, I'm flipping down or up horizontally. So I'm going to flip this down, and I want to make sure again that the point is the same distance, this time the same distance from the x-axis. So like if the point is up here, it's 1 unit away from the x-axis. I want to flip it down here, so it's again 1 unit away from the x-axis, but now it's below the x-axis rather than above the x-axis. Okay, let's try a few more before you get into your practice. No parentheses, this time it's outside. So I want you to think to yourself, if the negative is outside of the function, is that going to flip over the x-axis or over the y-axis? You can always check as well. If it's outside, it's going to reflect over the x-axis. So outside negative flips over the x-axis like so. And we're good. Okay. Now, this is a double whammy. I have 2 negatives, so I should immediately think if there's a negative outside the function and a negative inside the function, I have 2 different things going on. I have one reflection over the x-axis and then another reflection over the y-axis, right? Because I have a negative outside the function, and here I have a negative inside the function, inside the operation. Okay, so I'm going to do 2 reflections. Doesn't matter which one I do first. So I'm first going to reflect down over the x-axis, and then I'm going to reflect across over the y-axis. Okay, so it is possible to do both. You can reflect over the x and y when you have a negative outside and a negative inside. Okay, so what I would like you to do is continue along with this Google form. In the next slide, you're going to have 2 practice problems to try, and let me know if this video is helpful in helping you understand reflections over the x-axis and the y-axis. Thanks for watching. I hope you have a good day.